Hello, and welcome to this video to attempt to explain how to do this problem. So the problem that we want to work on is down here at the bottom. It says completely factor the polynomial over the real numbers, then completely factor the polynomial over the complex numbers. State all the zeros of this polynomial. And it is 4x to the 4th minus 4x cubed plus 17x squared minus 16x plus 4. All right, so to do this problem, we are going to use the rational zeros theorem, which is in the book, and I have the book here. If I get it open, here we go, and we'll get up higher here. So this is on page 269, and it's down here toward the bottom. The rational zeros theorem says, suppose we have a polynomial of degree n, so n is the biggest power of x, and all we have to do is look at this a sub n term, this a sub n coefficient, and the a sub 0 coefficient. All right, and so any rational root or rational zero of this polynomial has to have the form p divided by q, positive or negative, where p is a factor of a sub 0 and q is a factor of a sub n. All right, so if we go back to our problem here, get it back up here. Okay, so if we go back to our problem here, we are going to look for solutions of the form p divided by q, where p is a factor of a sub 0, that's the constant term, and q is a factor of a sub n. So the constant term is 4, and a sub n is 4, so that's kind of handy. All right, so our possibilities are, so the factors of 4 are 1, 2, and 4, right? So we could have 1 divided by 1, so plus or minus 1 divided by 2, plus or minus 1 divided by 4, plus or minus 2 divided by 1, plus or minus 2 divided by 2, plus or minus 2 divided by 4, and plus or minus 4 divided by 1, plus or minus 4 divided by 2, or plus or minus 4 divided by 4. Now, sorry for squeezing that in there. Okay, so now there it went, huh? So there we go. So pretend that says 4 over 4. A lot of these are repeats. So really, all we have to test here is if you just, because for instance, look, 2 over 2, that equals 1. And 2 over 4 is 1/2. So all we really need are these right here. Okay? So 1, 1/2, 1/4, 2, and 4. So let me write it a little nicer here. So there we go. There. All right, so those are the only rational numbers that we have to check. Okay? So that's actually, there's 10 of those to check. So hopefully you get kind of lucky. And fortunately in this problem we do, because you don't really know where to start. So I usually just start at the beginning with 1. That's the easiest one to evaluate. All right, so let's check x equals 1. X equals 1 will be 4 times 1 to the 4th minus 4 times 1 to the 3rd plus 17 times 1 squared minus 16 times 1 plus 4. All right, so that's going to be equal to 4 minus 4 plus 17 minus 16 plus 4. All right, so 4 minus 4 is 0. That's a plus 17 minus 16 is 1 plus 4 is 5. All right, so that's not 0. What we're looking for is we're looking for a number when we plug it in for x, we get 0. Okay? And if it's a 0, then x minus that number is a factor. All right, so 1 doesn't work. If we try x equals -1, okay, actually, I did this for a reason. So up here, if we plug in, this would be -1 here, -1 here, -1 here, and -1 here. So -1 to the 4th is +1 times 4 is 4. This is -1 to the 3rd is -1 times 4 times -4 is +4 plus. -1 squared is +1 times +17 is positive. -1 times -16 is +16, and then +4. That definitely is not equal to 0, right? Everything is positive. So 8, 25, 41, 45. Wow. So yeah, not equal to 0. Okay. All right, so let's try 1/2. All right, so plugging in x equals 1/2. Let's see what we get here. So 1/2 to the 4th, by the way, that is going to be 1/16. So we have 4 over 16, so that equals 1/4. Okay. 1/2 to the 3rd power is 1/8 times -4 is -1/2. This is going to be equal to 1/2 squared is 1/4 times 17 is +17/4. 16 times 1/2 is 8, so this is -8, and then +4. All right, so let's add these together. So 1/4, this is going to be equal to 2/4. See if I can make it look kind of like that. Yep. So 1 minus 2 is -1 plus 17 is 16. So everything underlined here is equal to 16/4, which is equal to 4. And then we have -8 plus 4, that equals 0. Yes, we did it. Okay. So that means that x minus 1/2 is a factor. All right, and we can actually multiply this by a constant and we still get a factor, okay? So I would like to multiply this through by something so that I don't have to work with a fraction. So let's multiply it by 2. And so 2x minus 1 is a factor. Okay? All right, so we have okay. So since 2x minus 1 is a factor, we can conclude then that our original polynomial is going to be 2x minus 1 times some other polynomial. Okay? All right, so we need to figure out what that polynomial is. So we're going to do division. So what we want to do is we want to, here I'll just write it like this. If we take this, our original polynomial divided by 2x minus 1, that equals the other polynomial that we want. Okay, so we're going to do long division. All right, so we're going to take 4x to the 4th minus 4x cubed plus 17x squared minus 16x plus 4 divided by 2x minus 1. Okay. So, if you remember how to do this, what we do is we look at the first term inside and the first term outside, and we compare them. What do I have to multiply by this term to get this? So I have a 2x, I want it to be 4x to the 4th, so I have to multiply by a 2 to get my constants right, and I need to multiply by x cubed to get the x's right. So that would give me a 4x to the 4th here. But then I'm going to take this 2x cubed times everything here, so I have 4x to the 4th minus 1 times 2x cubed. All right, and then we subtract those. So don't forget, we have to subtract both terms. So we have to distribute the minus sign. So here we have 4x minus 4 minus 4x to the fourth is 0. All right, that's 0. I don't have to write 0. And this is negative 4x cubed, and this would be plus 2x cubed, right, if I distribute the minus sign through. So that gives me negative 2x cubed. All right, and then I bring down the next term, which is plus 17x squared. All right, so now again, I compare the first term here and the first term here. I have a 2x and I need a negative 2x cubed. So I have to have a negative sign and I have to multiply by x squared. All right, so if I multiply by negative x squared, I get negative 2x cubed plus x squared, and then I'm subtracting all of that. Okay, again, negative 2x cubed plus 2x cubed is 0. This is going to give me a 17x squared minus x squared is 16x squared. And then minus 16x if I bring down the next term here, right? Bring that down too. Okay. So now I need a 16x squared. I have 2x, so I have to multiply by 8x. All right, and if I do that and then subtract, I get 0. Then negative 16x plus 8x is negative 8x. And then plus 4 to bring that down. So then I have to multiply by negative 4. And that gives me negative 8x plus 4 here. And that equals 0 if I subtract them, right? Okay, so there we go. So we can conclude then that there's my paper. Sorry about that. 4x to the fourth minus 4x cubed plus 17x squared minus 16x plus 4 is equal to 2x minus 1 times 2x cubed minus x squared plus 8x minus 4. Okay. So now what I want to do is I want to solve 2x cubed minus x squared plus 8x minus 4 equal to 0. All right. So the rational zeros theorem says that our possible rational roots are factors of 4 divided by factors of 2. So I could have 1 divided by 1, 1 divided by 2. I could have 2 divided by 1, which is 2. I have 2 divided by 2, which is 1. I already have that. Or I could have 4 divided by 1, or I could have 4 divided by 2. And that's 1/2. So I already have that. So, all right, only 8 possibilities. All right, well, fortunately for us, we know that plus or minus 1 are not roots, because we already checked them for the original polynomial, this x to the fourth polynomial. If x equals 1 was a root of this x to the third polynomial, then it would have been a root to this polynomial also, because again, if it makes this part equal 0, then we would have 0 times 2x minus 1 as the original polynomial. That would make it equal to 0 also. So we don't have to check 1 or negative 1 because we already know that those are not roots. 1/2 was a root of the original, but that doesn't mean that it can't be a root to this one also. Okay, and so let's check x equals 1/2. Okay. So let's check x equals 1/2 again. And so this would be 2 times 1/2 to the third power minus 1/2 squared plus 8 times 1/2 minus 4. All right, so this is going to be 1/8 times 2 is 1/4 minus 1/2 squared is 1/4, plus 8 times 1/2 is 4, and then minus 4. Well, how about that? That equals 0, right? 1/4 minus 1/4 is 0, plus 4 minus 4 is 0. Hey, we get 0. All right. All right, so now we need to do long division again. Okay? So we need to take our x cubed polynomial divided by 2x minus 1 again. So again, x minus 1/2 is a factor, which implies that 2x minus 1 is a factor. All right, so I am going to again take this x cubed polynomial here divided by 2x minus 1. All right, so it was 2x cubed minus x squared plus 8x minus 4. All right, so what I need to do is, again, just look here. I need to multiply this by x squared. It gives me 2x squared, minus, try that again, back up. I misspoke. So x squared times 2x is 2x cubed. There we go. X squared times negative 1 is minus x squared. So if I subtract them all, I get 0. So then I bring down the next term, which is 8x. And then I bring down the next term also because since this is 0 here, I just bring down the next two terms because, again, we would have a 0 here. And so now I need to figure out what I need to get from 2x to get to 8x. That's plus 4. I have to multiply by plus 4. And if I do that, I get 0 as my remainder. So I get x squared plus 4. All right, finally, we've arrived. So we can conclude then that our original polynomial is equal to 2x minus 1 times 2x minus 1 times x squared plus 4. All right, and 2x minus 1 times 2x minus 1 we can write as 2x minus 1 quantity squared. Okay, so completely factor the polynomial over the real numbers. There it is. Because why is that? X squared plus 4 doesn't factor, right? If you use the quadratic formula on that, you'll get plus or minus 2i. Right? So, or, solving that equal to 0, you get x equals plus or minus, x squared equals plus or, try again. X squared equals negative 4. Take the square of negative 4, you get x equals plus or minus 2i. All right? So you get 2i as that. So those aren't real. So x squared plus 4 doesn't factor. So this is completely factored over the real numbers. Okay, because again, if I take x squared plus 4 and use the quadratic formula on that, equals 0. I get negative b, well, let me rewrite it here to refresh your memory, minus b squared, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So b is 0, so this would be 0 plus or minus the square root of 0 minus 16 over 2 times 1. Which is plus or minus 2i. So therefore, all right, so this is the answer to the first part. Completely factor the polynomial over the real numbers. That's it. Then completely factor the polynomial over the complex numbers. All right, well, let me erase that here. Kind of hard to erase, so. Okay, so now I want to factor it over the complex numbers. Well, using what I just saw down here, that the solution to x squared plus 4 equals 0 is plus or minus 2i, I can use that to my advantage, because then I can write this as 2x minus 1 squared, and then this would be x minus 2I times x plus 2I. Okay, and so now this is factored over the complex numbers. And now the zeros of this polynomial are going to be x equals 1/2 that has multiplicity 2, and x equals 2I and x equals negative 2I. All right, so there we go. And that has stayed all of the zeros of the polynomial. It didn't ask for the multiplicity, but there it is anyway. So, all right. So there you go. I hope that this helped a little bit, and thanks for listening.